Okay, this is going to be the 5th video on how to find the volumes of solids using cross-sections. And in the first 4 videos, we work with a solid that had a parabola for a base. In this video, for the first time, we'll look at what would happen if the base of the solid was in the shape of a circle. So the problem looks like this. Find the volume of a solid whose base is the region bounded by the graph of x squared plus y squared is equal to 9. Now hopefully you'll recognize that as being the formula for a circle. So x squared plus y squared is equal to r squared. So in our case we've got a circle centered at the origin and the radius is 3. And if you do it in 3 dimensions it would look something like this. So this is going to be the base of the solid. And it says assume that you have cross sections that are perpendicular to the x-axis and have the shape in this case of a square. So again, what we'll do, sometimes the book will give you a picture of this, but it starts with some kind of a baseline, and the idea is just go in here and draw one representative cross-section, and if you drew it, it would look something like this. So here's a square that fits inside that circle, and this will be a cross-section of the solid that we're going to build up. Now, this is a single cross-section, as we've done in the previous videos. If you were to take additional cross sections, we'll say this one will have another cross section to here, you might have another cross section to here, and if you were to sum all these cross sections up, you'd come up with some sort of a solid shape. So we'll go back to our original one. We've got, looks like this. So this is a single cross section. If you put them all together, just to help you visualize what it looks like, the solid would look like this green shape right here. And I'll go ahead and remove the axis just so you can see it a little bit better. But the idea is if you sum up all these cross sections in the shape of a square, it will give you this solid. And what you're trying to do is to find the volume of this green solid using individual cross sections. So hopefully that'll visually give you an idea of what it looks like. In some cases, the book will actually give this sketch right here to get you started. Now to solve the problem, we're going to use the same steps that we've used in the previous videos. So let's take a look at those. And from the previous videos, hopefully you've watched those, we had these 6 steps. Now the first 2 steps involve drawing a sketch of the situation, and then the last 4 steps involve setting up and evaluating the integral. So let's run through these and we'll do it for this particular problem. So the first step says this, sketch the base of the solid in the xy plane using the boundary conditions. So let's see what that looks like. Now again, you could use this sketch out of your book, but just like we've done in the previous videos, in most cases it's easier to start with a sketch where you're looking at it straight down from the top. So if I were working this on a homework problem or on a test, I would, rather than using this sketch, I would set up a quick sketch that looks like this. So looking straight down on it from the top, first thing says sketch what the base looks like. Well, the base is in the shape of a circle. X squared plus y squared is equal to 9. So you've got a circle with a radius of 3, and if you were to draw it on here, it would look like this. And we'll go ahead and shade it in just to make it a little bit easier to see what the base looks like. So this is the base of your solid object, just like it is over here. But again, this one I think will be a little bit easier to work with on your page. So you've got the base of the solid sketched in, and that is step 1. So we'll go back to our steps again. So we sketched the base of the solid. Sketch 2 says now sketch a single cross section in the required geometric shape. So let's do that. And again, what you like to do, the shape in this case is a square. And to do it, we'll go back over to this, and actually let's remove this cross section for a little bit. To sketch a square into this thing, first of all you need a baseline to give you an idea of the size of the square. Once you've got the baseline, then you can go, and we'll put the section back in. From the baseline you can go up, over, and down, and that will define a square. Now you want to do the same thing over here, except it's not going to be quite as accurate a sketch, and just a rough sketch is good for the homework. So what I'm going to do is, just like I did on this one, I want to sketch a baseline that goes across this. So I'll go over to here and I'll say just pick a point from about here and say go down to say, oh, here. So there's my baseline there, just like this baseline's over here. Then I want to sketch a single cross section. So I want it to look something like this, but again, it's going to be a rougher sketch this time. So starting from the baseline, I would go up, over, and down. So on this one, just go up, and again, fairly rough sketch, over, and then finally down. Now, just like this one has a little bit of thickness, I'm also going to put a little thickness on this because you actually want to calculate the volume of this cross section. So I would suggest actually draw yourself in a little bit of thickness into that thing, just to remind you that it does have some thickness to it. So it looked like something like this. And then if it actually helps you a little bit, you might put a little bit of shading on that. So it's going to look something like this. So in my rough sketch, this square here represents the same thing that this one right here does. And that takes care of the second step. So I've got the base of the solid drawn, I've got a single cross-section done. Okay, now, next 4 steps. First of all, you need to come up with some kind of a general geometric formula for whatever the shape is that you're given. So in our case, the shape is a square, so we just need the general formula for a square. So the area of a square, so in the most general form, and I'm just going to put it in the simplest form, the area of a square is simply whatever the side of the square is squared. So there's a general formula for finding the area of the front surface of that cross section. And we'll go back to our rules again. So I've got a general formula. Now the next step, and this is in most cases the trickiest part of the whole problem, find the area of that single cross section, but this time put it in terms of your picture, in particular in terms of x. So let's see how that works out. So what I'm going to do is I've got to do this. I came over, here's the baseline right here, and I came over some distance on my picture. I came over some distance right here, x. Then I went up, if you go from here to here, the coordinates of this point right here would be some distance y. Now, by symmetry, since this thing's a circle, if this distance is y, then this distance right here would also be y. And so if I took the entire side, the length of this entire side from here to here, that's going to represent the side of that square. And in my drawing, the way I've got it set up, y plus y, that side would be 2y. So I know that the side of my square is 2y. So this side's 2y, this side's 2y, this side's 2y, and this side's 2y. So let's go back to our rules again. So again, we want to change it from a general formula into our particular problem. So what I've got here is this, I know it's the side squared, but the side is 2y. So in place of the side, I'm going to go ahead and put 2y, which agrees with my problem, squared. And if I square both those, I would get 4y squared. And what this is the cross-section area. So cross-section area, but with one important problem. That's in terms of y. So I've got it. It's 4y squared. That's the cross-sectional area. But the problem is this right here. Right now it's in terms of y. And what I need, when I find the volume is going to be integrated with respect to x. So I need to get this thing in terms of x. So in this same step, the next thing to do is to change this cross-sectional area in terms of y and change it in terms of x. And we'll do it the same way we did in those previous videos. To do that, use your boundary conditions up here at the top, and you can find y in terms of x. So let's try that and see what that looks like. So I've got x squared plus y squared is equal to 9. And I think I'll go ahead and move it down. Let's put it right in here. So start with the boundary conditions. If x squared plus y squared is equal to 9, that means that y squared would be 9 minus x squared, and then take the square root of both sides, and you would get plus or minus the square root of 9 minus x squared. What this is, this would be y in terms of x. Now graphically, what that gives you is, that means that this distance right here, from here to here, this would be the plus the square root of 9 minus x squared. And this point right here would be minus the square root of 9 minus x squared. So graphically, that's what you've got. But what we want to do is this, we want to take advantage. Now that you know that y is equal to this, just take this and substitute it back in up here. So what we're going to have is 4, but in place of y, put what y is equal to. Well, that's going to be the square root of 9 minus x squared, and the quantity is going to be squared. Now again, the plus or minus won't matter, because when you square it, it'll turn positive. So in this case, the square and the square root cancel out, so you'd have 4 times 9 minus x squared And if you multiplied that 3 by 4, that would give you 36 minus 4x squared. And what this is going to be, it's going to be the cross-sectional area. So you've got the cross-sectional area. But this time you've got it like you wanted it. You've got it in terms of x. So now you've got it set the way you want to. So that's going to be the cross-sectional area in terms of x. So what that's going to be, graphically again, it's going to be just the area of this face of the cross-section. Now to get a volume, if you multiply the area times the thickness, remember the thickness of this thing, this little part right up in here, is dx. So the thickness of our cross-sectional area would be dx. Okay, let's go back and take a look at our steps again. So we've now got the cross-section area term. Now the limits of integration, you can get that right off the picture. So we'll go back to the picture, and again, if x squared plus y squared is equal to r squared, you know the radius is 3, so this goes from minus 3 here. Over here it goes to plus 3. So you're going to integrate it from here to here, and it's going to go from x is equal to minus 3 to x is equal to a plus 3. So you've got the limits of integration. And again, back to our rules again. Now it's just a matter of evaluating the integral. So the volume of the entire thing would be the volume of a single cross-section, and then when you take the integral, you have the volume of the whole green solid. So let's go ahead and set that up. So now, it's just a matter of finding the volume. So the volume is equal to, and again, using the formula, it's just the integral from, in our case, minus 3 to 3 of the cross-sectional area, and that area is 36 minus 4x squared, and then dx. So this is the area of the cross-section. This is the thickness of the cross-section. So area times thickness would give you volume. And if you evaluate that integral, you'll have the volume of the whole thing. So this is going to, if we ran through this integral, this would be 36x minus 4 times, and this would become x cubed divided by 3. And it would all be evaluated from minus 3 to 3. So we'll run through that real quick. And that's just a matter of, first of all, plug in the top 3. So we'd have 36 times 3 minus, and we'll go ahead and put the 4/3 together. And then 3 cubed. Then minus, and now plug in the negative 3. So 36 times a negative 3 minus 4/3 times a negative 3 cubed. And if we run through all that, we would come up with, this would be 108, then minus 36 minus, and this would be negative 108, and a plus 36, which would give you 72 minus a minus 72, and that's all going to be 144. Now this would be cubic units, whatever the units happen to be. And what this is going to be, this is going to be the volume of that green solid. So graphically, let's go back up the top here and put the green solid back on here. What you found, the volume of that green solid right there is 144 cubic units, whatever those units happen to be. So again, real quickly, just on the steps, let's take one quick look at them again. The first 2 steps were to sketch the bases and so on. Then we ran through these 4 things. So let's take one last look at it in respect to our problem. So first of all, you sketched the base, and you drew one representative cross-section. Then you started with a general formula. The next thing was find a general formula for just a single cross-section. And again, this is going to be the general formula, just in the vaguest terms. So it's just going to be the side squared. Then you change that general formula into a specific formula for your problem. First of all, you got it in terms of y. Then you use the boundary conditions to change it in terms of x. So you end up with a cross-section of a single section in terms of x. And then it's just a matter of putting it into this formula. So the integral of the cross-section with respect to x. And when you ran through that integral, so there's the area of a cross-section, and there's the thickness of a cross-section. Do the integral, you got 144, and it gives you the volume of the whole thing. So again, if you follow these steps, just like in the previous video, it makes a pretty good guide for getting through these problems. So that's just an example of a problem that has a circular base with square cross-sections.